Okay, today let's talk about the PACS components. The components of a PACS system are the modality, the F5 content switch, the DICOM servers, the PACS database, the NAS, the archive, the IMS, and the review station. Let's go through those individually now. The modalities and their associated post-processing stations acquire and create images. Once these images are in their presentation state, they are sent to PACS through DICOM connections. At the end of this lesson, I'm going to use a tracer methodology to take you through how studies and images go from the modalities into PACS and then out to the review stations. I will talk about what happens at both the study and image level, but first we need to talk about each of the components. Let's start by considering how many application entities a large health system might have. A small health system like the one I worked at in Georgia had 28 different AE titles that could send images to PACS. For a statewide system like the one I worked on in Hawaii, there were 102. Imagine all these different AE titles trying to send to PACS. It has the potential to create a network bottleneck. So quick refresher, how modalities send. Do modalities send the whole image at once to PACS? No. Each image is broken up into small sections and sent as data packets. Just for one image, there are now 9 data packets that need to be sent to PACS. And when you consider that it's just one image from one modality, you start to get a sense of how busy a PACS DICOM network can be. PACS has to take in those 9 data packets and store them together as one complete image. To do this, PACS uses DICOM servers. The DICOM servers respond to DICOM association requests from the modalities and process the DICOM send requests. Every PACS system will have several DICOM servers to handle the amount of traffic coming into PACS from the modalities. And it's kind of like this picture of the Magic Kingdom where you see the green lights are where the cars, which would represent images and studies, are going into PACS, and you see that other lanes have cones and red lights. Those DICOM servers or lanes aren't open for images to go through right now. To make that more complicated, some places use an F5 or content switch. An F5 content switch is the same thing. It's an optional piece of hardware that sits between the modalities and the DICOM servers in the image send chain. The content switch serves as a traffic monitor directing modalities to the least busy DICOM server. Imagine if each modality tried to connect to DICOM server 1, and if it was busy, then it tried to connect to the next DICOM server. This would be very inefficient and take longer to send studies. Also take into account that most vendors limit the number of connections a modality can make. A modality might be only able to try a few connections at a time. Or, imagine if certain modalities were configured to send to certain DICOM servers. The DICOM server for Nuke Med might only get 8 to 10 studies in a whole day, while the DICOM server for X-ray would get hundreds of studies a day. This is not a good use of your DICOM servers. It's not a good way to balance the load. So ideally, the F5 works as a load balancer, directing the next incoming DICOM association request to the next available DICOM server that has the lowest utilization. This has several benefits, and it's the fastest way to transfer images. It keeps all the servers working at similar levels, and if a DICOM server goes down, the F5 will just adjust the workload to the working DICOM servers. It's transparent to the user how many DICOM servers are actually running in that type of scenario. PACS database server. The database server is the brains of your PACS system. The database knows where every image and every study is stored in the archive. The database also holds all the order and ADT messages that come from the RIS for a certain period of time. Not all orders get images. That's very important. Let me say that again. Not all orders get images. So after a fixed period of time, order messages are purged from the database if they haven't been matched up with images. It also contains all the patient information for PACS. It matches up the incoming images with the order information and directs the DICOM servers where to store the images. For outgoing images, it tells the image manager service where to find the images, and it provides the patient information and order information for the DICOM modality worklist. Obviously, this is the most critical component of the PACS system. If it's down, the whole system is down. Consequently, most PACS systems have 2 database servers in a clustered model. A server cluster is a collection of servers called nodes that communicate with each other to make a set of services highly available to clients. If one node fails, the other will immediately take over, keeping the system running until the failed node can be fixed or replaced. Simple English, a clustered system, 2 database servers. Primary is node A, backup is node B. As soon as node A fails, it immediately starts using node B, copies all the data there. It's transparent to the user, and it gives the PACS admin time to jump in and fix node A while the system stays up. That's why most people use a clustered environment. Okay, I'm going to stop now because this is just over 5 minutes, and I will continue this as a part 2.